Hi everyone. Today I would like to share with you about boundary layer. So this is the introduction about boundary layers. The main purpose of for us to study the boundary layers is about to know or to calculate the lift and the drag force. But in this syllabus we are focusing only the calculation of drag force. So what is lift and drag force? Lift force is actually a force that works or acts on certain object here in y-axis, while drag force is the resistance act on this object on x-axis. So it could be simplified like this diagram. So normally people will say that lift force is force that could lift your model, and drag force is actually force that would give you certain type of resistance. So according to this diagram, we could say that drag force is actually the total force that acts on x-axis, while lift force is the total force that acts on y-axis. In some automotive application, we might be put spoiler on our car to increase downforce. Downforce is actually some kind of lift force, but it works on the reverse direction. Lift force will lift object, while downforce will works from top to the bottom. Okay, the existence of lift and drag force is actually influenced by two big elements. So let's say we have one small area like this, so we mark it as dA. Then we have a free stream velocity. We mark it as capital U, flow from left to the right like this. So this will create, when the free stream velocity here flow around this object, they will create faster region velocity and slower velocity region. So the difference of velocity here will create pressure difference. So the velocity will move faster on this area, so the pressure here is lower compared to the pressure at the bottom here. The difference of pressure here will create lift force, and they could disturb the stationary of this object. So because we have different of velocity here that create different of pressure, we could say that the one force occur at this situation, and we could simplify it by using the Bernoulli equation, and we could say it is force is equal to pressure times area. Pressure is the pressure that occur on the surface, and area here is the area of the surface. The second one, so we must agree that when the wind flow on a surface, there is molecules that stick very hard on the surface, and it will create shear stress. So we learned about this in our previous lesson. We could say that because of the friction of the fluid on the surface, it will create another force that we could say it is equal to shear stress times area. So then we need to combine these both forces. For example, we have one small area like this, so located inclined at certain angle. So we could say that force from pressure will act perpendicular on the surface, and we could draw its arrow like this. That force can be written as pressure times area. So when the free stream velocity moves along this surface, we could say that another force exists, which is shear stress time area. Because we have two types of forces here, and we need to solve the resultant forces on this object, we need to split it into its component forces. So for F equal PA here, so we could say that we could distribute it into X and Y component, which is PA cos theta for X component and PA sin theta for the Y component. So the same thing goes to tau times A. The X component is tau A sin theta and the Y component is tau A cos theta. Then we could conclude that drag force, normally we will write as Fd here, is the compilation or the sum of forces that act on X axis. So from the diagram here, we could say that for X axis it is PA cos theta and tau A sin theta. So we could say that drag force is the summation of P cos theta dA plus tau sin theta dA, while lift force is the summation of force that act on y-axis, and it can be written like this. So this is the common equation to calculate drag force and lift force. So drag force is equal to CD times 1 over 2 rho A U square, and FL is equal to CL, which is coefficient of lift, times 1 over 2 rho A U square. So CD and CL is coefficient of drag and coefficient of lift respectively. Rho is the density of the moving fluid, A is the area, and U is the velocity of moving fluid. At these situations, so please make sure that sometimes we need to take the projection area for this calculation, not its real area. So we will discuss about the later on. For example, we have three objects like this. For example, we have a sphere, we have a cylinder at this orientation, and we have totally same cylinder, but it's falling down like this. So for falling sphere like this, so the area is actually A equal pi r square. So it is equal to its projection area. You just imagine that you have a source of light at this point, and the shadow that occur is actually a circular shape. So same goes to this one. So the projection area for this cylinder can be calculated like this. And for this cylinder, because the projection area is rectangular, so we need to calculate a rectangular here as its area. Drag force can be divided into two major types. One is form drag and one is skin friction. So the simplest explanation about this is the form drag is actually drag that occur because of thickness of certain object, and skin friction it is because of fluid moving and create resistance on its surface. It can be seen here that for thin flat plate like this, so because the thickness of this plate is very small and we could neglect it, we could say that the form drag is 0%, while the skin friction or resistance that occur on its surface is 100%. So when the thickness is a little bit thicker, like this aerofoil, we could say that a part of the total drag force is come from form drag, and the skin friction it might be around 80 to 90%. So, and then for this sphere, for example, or this cylinder, we could say that the form drag is 90% and only around 10% that contribute to its skin friction. It is because for objects that curve like this, it is still a possibility of fluid to moving and create resistance or friction on its surface. While if we use same thin flat plate like this, but the orientation is vertical like this, we could say that there are no skin friction acts on this surface. However, the form drag will increase into 100%. Thank you. Please subscribe this channel, C23 Classroom channel. Thank you for watching.